So the idea is a little bit that it goes back to an idea that I had a while ago, that the way that we have built Joomla has actually had a large impact on the way that the web has worked and the web has evolved, specifically how people are managing content online. But it works vice versa too. The web has also shaped how we have built Joomla. And I was like, okay, but how did that happen? Like, if you go back in time, what were the triggers and the ideas and the technology that were there, which we, without much question, started building Joomla on top of? That's the first part of the talk, and then we go from there. So, yeah, invention is, humbly admitted, something that's a creation process, but the creation process needs substance. You need something. You cannot create something out of nothing. And for Joomla, the same is true. Joomla was created on the shoulder of many giants that went before us. The first one is the computer network itself, right? When ARPANET was created, actually 2 pictures I found. The left, you find the guys that actually worked on interconnecting the 4 different hosts of the ARPANET, the little team there. And at the right, people are implementing what was called the IMP, the Inter-Messaging Protocol, which was the predecessor of TCP/IP, and this is how the 4 nodes were interconnected. So Thomas Merle and Roberts created this, 3 devices or 4 devices, Utah, Stanford, and University of California. When TCP/IP was developed and created, they changed the name from ARPANET to Internet. I was 1972-ish, I think. I'm not 100% sure. So today there are 1 billion sites on the internet. Like, you have blogs, commercial sites, government sites. There is a lot out there. But they have 3 things in common. All of them. They all need hosting. They all need a domain name, otherwise you cannot reach them. And of course, they need something to create a website with. Now, the last one we all know, this is where Joomla comes in, or Mambo comes in, or Drupal or WordPress comes in. The domain name is easy. The hosting is a different story. It's an interesting story, actually, when you go back to understand, like, how did hosting actually happen, or the hosting that we as Joomla started using. And what can we learn from that and towards the future? So 1999, the web is born. The first ever web server was 1990, when Tim Berners-Lee put up a Nextcube on his desktop, and he basically said, this is the first ever web service. And there's this little sticker on top that basically says, this machine is a server, do not power down. Because otherwise, the internet, or the ARPANET, or what it was called back then, it was already called internet, would basically go down. In 1991, when that first web page went live, he started working on what was called the World Wide Web. And then you also have, like, the first ever web page, which looks a little bit like this. So there was not much there. It's a little bit of HTML, and this was the first ever web page that he created at CERN. An interesting thing happened along the same time. 2 years before that date, when the internet came about, in 1989, the GPL was released. The first version of the GPL license was released, and that was interesting for different reasons. Because at that time, a lot of people were already working on creating software and sharing that software with each other over email. Mostly over email, and some over bulletin boards and other ways, IRC sometimes, to exchange information around. The GPL was helpful because it allowed people to have a legal base to do that with, to exchange code. The GPL initially is actually much more than just a legal document, just a little license that we put on something. It's a manifesto for creativity. It allows us to perpetuate ideas and perpetuate code without question. And this is also how Linux in 1991 and Linus Torvalds picked it up. Linux was originally not GPL. When he created it in 1991, he basically drafted its own license, which was, in broad terms, very similar to the GPL. It was something like, this should be free, it should not be for any cost, people should be able to give it to each other, so he drafted something. And then the GPL was created, and Linus basically said, okay, let's adopt that for Linux. Actually, a funny story about Linux is, do you know what it was originally called? FreeX. Because Linus was like, I don't want to call it Linux. It's a little bit like thumping my own horn too much. So let's figure out something else. So he called it FreeX. And then his coworker went like, FreeX, this is a really weird name. Let's not do that. So he stood with Linux. So 1991, Linux. And this is what Linus had to say about that. He said, like, with Linux, we took a rather more pragmatic approach to code sharing. Right? The GPL for Linux was much an engineering choice than anything else. It wasn't really a imperative or the philosophy about it. It was more like, okay, I want to create a distribution and a kernel that people can easily contribute to. The reason, because he, before that, used something called Mimics. And Mimics, the creator from Mimics was not really open to contributions. It was really hard to contribute a patch and a change. And Linus basically said, like, that needs to change. I want to have a much more open development approach. People should be able to send me a patch over email, send me some code, and then we can talk about it, and I can incorporate that. So the GPL for Linux was much more about how can we get the engineering flow together than how does this work philosophy-wise and what can all happen with it. It started with Linux, and this is where we kind of are at. This is only 2007, so this is 10 years ago. But this is how all the Linux distributions grow over time. I think you are, right? Somewhere in the middle.
Yeah, definitely.
Somewhere in there. So this is how they all grew and branched out. And this is only since 2007. I couldn't find more. Well, I could, but then the chart becomes like this big. There are 3 ones that we know or use a lot, or the more predominant ones: Debian, CentOS, and Ubuntu. And the one that is being used most today is probably Debian Ubuntu combination. CentOS still, but a little bit less.
No, CentOS changed.
Okay.
It's no longer what it was.
Okay.
The free version of Red Hat.
Right.
So it's now actually more like an alpha version of Red Hat Enterprise.
I didn't know that.
Yeah, so that.
Okay, no, it doesn't matter. Yeah, but the idea here is that when Linux created Linux, you had this like you had a kernel, and that kernel was very powerful. But if you wanted to build something with it, you had to compile everything yourself. You had to go out and compile all the different programs together and build your own distribution. So distributions came in and they said, like, let's solve this problem by pre-building something according to our rules and our ideas and our configuration. And this is how the different distros happen. Most hosting today is probably going to run Debian, Ubuntu, and more advanced hosting might go CentOS or might go somewhere else, but it's going to be Debian, Ubuntu. Reason that I'm bringing this up is because this is the base that we started building upon. We started building on what we called 20 years ago, 15 years ago, the LAMP stack. Right? We had Linux. And it was not pure Linux, but it was a distribution of Linux. We had Apache, we had MySQL, and we had PHP. And we took them for granted. We never really questioned why, because simply they were there. They were available. Apache was created in 1995. It's actually quite interesting. Around the same years. Apache in 1995. Brian Bellendorf is one of the creators, the guy who also did SourceForge and Collabnet, and is behind a lot of innovation in the open source industry, was one of the co-creators of Apache. So originally created as a fork of the NCSA HTTPD server. And in 2009, which is already 10 years ago, 100 million websites were running on Apache. MySQL released around the same time, started in 1994, released in 1995. Created by David Exmark, Alan Larson, and Michael Monty, Windius, and originally developed and started in 1994, like I said, right? And then a year later, it became available. That, and then of course the last one, 1995 too, PHP FI, because the original name for PHP was PHP FI, function interface, and then later it became just PHP. How Rasmus created it. It was a simple CGI interface for C code so that you can actually call simple C functions through PHP. PHP stood for Personal Homepage Tools. A lot of people think it has some weird name, but it basically stands for that. And this is where we started building on. So we took a Linux distribution in the very early days, probably often Debian. We took the LAMP stack, and hosting started happening from there. And the very initial hosting, which didn't use that stack properly yet, was probably GeoCities, bought by Yahoo, and later decommissioned. I think in 2009 they stopped having GeoCities. But that was the first ever shared hosting environment where you could upload some files onto and you could have your own little website going. And then others happened, GoDaddy in 1997, SiteGround in 2004, which is already a little bit later, ICDsoft in 1999. So HostGator, DigitalOcean is probably one of the last ones in 2011 that we know of. So this is how the hosting environments that we are starting to deploy Joomla on started to grow from there. And they all have a Linux distribution and a LAMP stack in common. And they all have the same configuration for that stack. And they all have the same PHP extensions installed for that stack. And they're all missing a whole bunch of PHP extensions because they don't include them. So we are only using a very small percentage of the capabilities of that whole stack. Go back in time, a little bit of a trivial. GeoCities had 1 megabyte of disk space, which was quite a lot. And you got it for free. Tripod had 2 megabytes. And AngelFire only had 35 kilobytes of disk space on their plans. That were the 3 initial hosting providers in 1995. So if you take into account that we have 100 gigabytes, then all of that it's peanuts. It's nothing almost. So like I said, like shared hosting uses only 1% of Linux's true potential. And that's the point. That's also the realization that I had. Like this is strange, and we're still dealing with that only 1%. We're still building on that only 1%. We could do much more with Joomla. We could do much more with applications that we build on top of that stack had we more access to it. So Linux for the win. Linux is awesome. We don't want to go anywhere else. But we need to be able to build custom stacks. We need to find ways to do that so that we can tap into the full potential of what Linux has to offer. And this is where recent innovations slowly starting to come in. So you have what you call now cloud-native applications, where you're going to offload some of the functionality that a distribution would normally do, like logging, for example. You have cron jobs, for example. Those are all things that Linux by default, or the Linux distribution by default will do. You're going to take them out, and you're going to have them in the cloud, and you're going to focus your distribution on what your application really needs. So how can you go cloud-native with Joomla? It's an interesting problem, and I started working on it a year ago. Like, what is there available, and how can I make it easy for people to use? Initially, you end up with Docker. Of course, there is not much else. There is something else, but it's really hard. So you end up with Docker, and then you go, okay, so where can I do my Docker hosting? And then you're starting to learn that Docker hosting isn't so trivial. Because Docker has a mantra of 1 container per service, which basically means my Apache, my PHP, my SQL, they all need to run in a separate container. Then I need to deploy those separate containers and orchestrate them together. That is possible if I deploy my own Docker host on a virtual private server. But is there any other cloud offering there that makes that easier for me? Because it should be as easy as installing Joomla. And there isn't really, or there wasn't really. Anyway, Docker was created by Solomon Hykes in 2013. What is really interesting is that Docker hadn't been possible hadn't it been for an innovation that was integrated into the Linux kernel in 2014, which is Overlay 2, which is an overlay file system. Because Docker creates these overlays of things, and it has this overlay file system that looks like a normal file system and works like a normal file system. It's on top of that innovation, that overlay file system, that Docker could build its containerization. Docker is really great. It's really awesome. It's really useful for local development. And I must say that I've been a little bit of a, hey, I can do this with Vagrant, so why should I go to Docker? And then I was like, okay, I need to put that aside embrace it and see what it can do. And I've learned in the last year that Docker is really great for local development. I can do really great stuff with Docker. Problem is, it's hard to deploy. So how do you solve that deployment problem? How can you make it as easy as installing a Joomla as in deploying Docker into a hosting environment? Firecracker, the date is wrong. Firecracker is an answer to that. Firecracker was created in 2018 by AWS. It's actually AWS's first real free software project. So that basically means that it's not just a product that they sell. There's a GitHub, there is Git, there's a community. You can send patches. There are people working together on it. The thing with Firecracker is that it was based on the Chromium OS virtual machine manager. They basically forked the Chromium OS virtual machine manager, which is written in Rust. And they used that to manage virtual machines, KVM, Linux kernel virtual machines in their environment. You get very fast, very tiny virtual machines that Firecracker can manage. And the great thing with Firecracker is that you can send it a Docker image. And it will transpile that, and it will run it to Firecracker. The only thing that you cannot do is you cannot really say, I have a Docker and I have 4 containers, Apache, MySQL, PHP, and Linux. I have 3 containers in this sense. And I'm going to deploy them in Firecracker because Firecracker would need to change that into 3 virtual machines. That's not the idea. Because in a virtual machine, we don't run services separate as containers. We run them as services inside the virtual machine. So the solution to that was, OK, I need to start thinking different about Docker. Instead of a container per virtual machine, per service, I'm going to create a stack that contains everything that I need. So I have a multi-process container that contains Apache, MySQL, PHP, and runs on Ubuntu in this case. That allows me to just run it locally as a single container and deploy it on any Firecracker supported host. There are not that many yet, but they're happening. One that exists, and this is, by the way, in this whole talk, the only thing that is commercial that you need to pay for. They have a very nice free offering too. You can run quite a lot without paying anything. This is their entry level. But this is the hosting you still need to pay for. All the other technologies in the stock are open source, and you can run them on your own. Fly.io is one of the early and first providers that are building a completely separate network and infrastructure on Firecracker. They're not using Google Cloud. They're not using Amazon AWS. They're using their own bare metal servers, which they are deploying Firecracker upon and orchestrating everything for you. That creates an enormous independence because they're not related to any of the big guys. And it creates an enormous amount of power because they're in full control of what they're doing. For example, the Fly.io network has nodes in 25 countries. And you can create the real distributed applications with it. I can deploy a Joomla in Brussels, Amsterdam in this case. I can deploy it in LAX in Los Angeles. I can deploy it in Sydney, and I can deploy it in Singapore. And I can just tell it to do that. Click deploy, and it deploys it out over those 4 regions. It's really, really powerful. So what I did was I took all those things and put them together. I said, like, I want to do Docker because Docker makes it very easy to do local development. But I also want to make it easy to deploy that solution or deploy that website or application somewhere. You can deploy it with Docker. Yes. And it won't be that hard because it's one container, multiple services. And you can also deploy it on Firecracker. And it will not be hard because it's multiple services. It is, in a sense, just like shared hosting works. But it's your own shared hosting. It's shared hosting that you control fully. It's a fully custom stack. So you can not only install every PHP extension you want, you can also install any Linux tool or library that you want and that you need, which opens you up to an ecosystem that is vastly more powerful than what we have had access to today. So what have I built? Cloud native LAMP stack. M in brackets because the MySQL can be disabled or enabled. Reason, MySQL is a little bit of a resource. It sucks up quite a lot of resources. 350 megabytes of memory to run it, and then it's not just running really yet. It takes a little bit of disk space, 500 megabytes of disk space. That doesn't really matter much, but it matters when you're building containers. You want your containers to be as small as possible so that you can easily send them over and deploy them. Works on Docker and Firecracker, offers out-of-the-box support for Fly, and basically allows you to deploy a Joomla site in less than 5 minutes. Things that I've added, open metric support. So all the metrics that the server gathers can be sent out and synced into a solution like Grafana. Grafana you can run natively, you can run yourself, self-hosted, or you can use their online offering. All the exceptions and all the traces to see how performant the application is are also being sent out. They can be captured by Sentry. Sentry is an open source solution that you can install yourself, or you can use their cloud offering. And it has a built-in HTTP API to manage the server remotely. So you can basically easily see what the server is doing and tap into it. There is no SSH, because you don't need to get into the server itself, at least in this case. With Fly, they have their internal network that gives you that power. And if you want to deploy it somewhere else, you will already get into the Docker host, and then from there, get into the container. So you don't need to have SSH per container here. Also increases security and lowers the complexity of setting all of this up. Architecture-wise, I stumbled upon this very interesting PHP extension already 2 years ago, but then didn't really bother about it because most of the information that I could find, actually 3 or 4 years ago even, most of the information that I could find was in Chinese. The thing is called Swool, has been forked recently in 2 projects. We all know how that goes, Brian, right, the forks. So you have Swool, which is the Chinese developers, and you have a more English group called OpenSwool. Now, there's a nice website, openswool.com, where you can find the English documentation for Swool. It exists for 7 years. It's very much used in China. China, all the bigger companies, Alibaba, to name one, but all the big guys, all the cloud SaaS companies are all doing PHP with Swool. It's really big there. And it's incredible how small it is in Europe and in the US. Most people don't know about it. They dismiss it as, you know, why would we do that in PHP? Swool is comparable to Node.js and Go. It's basically an async solution to build applications, microservices, servers in PHP. Yeah?
Is it like the life cycle of JavaScript, where you have
Comparable.
the same?
It uses a reactor internally, so it has an event loop with a reactor, which is similar to PHP, and internally it uses coroutines. So a coroutine is a very lightweight. It's not a thread, but it's comparable with a thread. It runs in userland. So the coroutines all have access to the same memory space, and you don't have any of those problems. But what Swool basically does, very simple terms, it solves the problem of blocking I/O. When we execute Joomla and we need to render a page, that process is slow. And the reason it is slow is because Joomla needs to talk to the database. It needs to talk to the file system. It might need to talk to an HTTP API. Each time it does an I/O operation, it needs to wait until that I/O operation returns. And it does them sequentially. It cannot basically say, I'm going to fire off the database, and I'm going to tell it to fetch data, and I will later get back to this, but I'm going to continue running. That is not something that PHP traditionally in a PHP FPM environment can do. Swool can do that. Swool can basically run async. I can fire off a database query, and I will go back later when it has completed. I can run an HTTP call, and I will go back later when it has completed. That is very similar to how Node.js works. It's also very similar to how Node works. Actually, internally, the libraries that are being used to handle the eventing on a Linux level are the same. The same implementations that Node uses are things that OpenSpool also uses. It's the same how Go works. So on a lower level Linux implementation, they work in the same way. They get the same performance. The only difference is that the coroutines in Spool are, they're a little bit inspired by what Go does with Go routines. Node.js solves the problem with promises, but do that. And I like the coroutine approach much more than the promises approach. It gives you a much cleaner way of coding. Your code really looks like normal sync code. It just flows, you can read it, and you see when something calls off, and then when you wait for it, when it comes back. Anyway, this is a topic for another talk, but
Does it come back to the same idea of async await?
yeah. Well, not really. You program that into it. Right? So you can create your own libraries, which I did, that does that. What it basically does is, it will, simple example. Let's say you're going to read a file and have my coding flow, and I'm going to read a file here. I could just wait till the file is read, and then the code continues. I could wrap that reading of the file into a coroutine, and Spool has this thing what they call coroutine hooks. So Spool understands certain PHP code, like, for example, fopen, or get contents from file. When it sees that function, it goes like, hey, this is an I/O function. And this function is being wrapped into a coroutine, which basically means I can now async run this. And then it will fire off that function, and the execution of the program will return, will continue. If you then want to go back to fetch the result, then you wrap that into a coroutine channel, which is a blocking structure. So you can fire it off, which is a fire and forget, and then something has just happened. Or you can basically say, I'm going to wrap the result of this later into a channel, and then get it. This is a whole new talk, right? I just want to show what is possible here. Why is this important? Because okay, we can do this in Go, and yes, we can do it in Node, and then we need to install a Node.js server, or we need to install Go into Linux, and we can do that. But this opens you up to the whole PHP ecosystem. I don't need to worry about PHP, about Node.js or Go libraries and how they work in another language. I can use everything that I already know.
You can also use React PHP. That's also the same.
Yes, but React works in PHP itself. Performance-wise, very big difference. I'll show you. So this is the performance chart of Spool compared to other PHP frameworks. So this is not, Spool is not really a framework, right? Spool is more a PHP extension. So you would still create your own little framework around it, or use it combined with other frameworks and make it run async. But what you see here is that there is nothing in the PHP world that can top Spool performance. Not by tenfold. The only thing that comes close is Comet and AMP. And then you have basically Symfony framework, but then with an adapter for Spool to give it additional performance. And then you have Falcon. Falcon is a PHP extension that also provides additional performance by wrapping a lot of MVC. Exactly, right? It's written in C. So that's also performant. But if you go look lower, and you go look here, Symfony Cake. Symfony has a 2000 performance measurement, which is 4% of the performance of what 100% of Spool can deliver. The difference between Spool and, let's say, a CodeIgniter is 10 times. So it's fast. It's really fast. There is almost no comparison, no difference between doing something with Go and doing something with Spool. If you put it into the bigger picture, then I didn't take all of them because the list would become too long, but this is Go, Node, and PHP compared. And then you see that Gearbox and Fiber Prefork, which are Go solutions, are still coming on top. They do a little bit better, but the difference is small, right? Spool sits at 40,000, which is 70% of Gearbox. And Comet is still here in this list, and then things get lower, 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 and then you end up at Node.js, which has a performance which is only 10% of the top one. So Swool compares in performance with Go. It's faster. It's really faster. And it's incredibly powerful. So what have I done? This is a little video. I'll play it in a bit. So what have I done? How am I using Swool? I'm using Swool to implement additional services in my multi-service container. For example, the API service, which allows you to connect over an HTTP API with the container, is written in Swool. For example, the open metrics, which is actually fetching metrics from different exporters and exporting that as a single stream, is written in Swool. Because Swool allows me to do non-blocking streaming I/O without using any memory. It's become
extremely interesting for the next years.
Yeah.
The streaming bar is coming.
I'm glad. I'm glad you can see that. So I'm happy the right people are still in the audience. So this is a little demo. What I did was I finished Joomla Tool Server, the first initial version, 2 days ago. This is just booting it up, downloading Joomla, booting MySQL, creating the database, installing the database, and have a site running. So I'll let it run. It takes 2 minutes, but I'll let it run so that you can see. Maybe I'll pause it. Well, cannot hardly zoom in, so let it just run. Online, then you can check it out in more detail. So what it is doing here is, this is all the configuration that it's loading from the internal process manager. I'm using S6 overlay, which is a supervisor for Linux. It's comparable with systemd, but call it the smart little brother. Systemd is not running in this box at all because it's too heavy. I don't need it. Then it's starting to download everything from Composer. So Composer is available, and I have installed something called Composer Merge. So you can have multiple Composer files that merge together into one big one, and it will download all of that. Which also allows you to override the Composer that sits in the base box. So I can build a base box, and if you implement your own Composer file, and you say, hey, I don't want to have that version, I want to have another one, then that's no problem. So you're never stuck with anything that the base box provides Composer-wise. And this is all the services that it's booting up. So there's a file service, an API service, a fast CGI service, a MySQL service. This is MySQL booting up, and a PHP-MyFPM service. And then I have 2 exporters running, one for PHP-MyFPM and one for Apache. 7 services in total. What it's doing now is it's starting the server, and it's installing Joomla, and it's downloading here, so it's waiting a bit. It needs to fetch the Joomla package from GitHub. So that takes a little bit of time, and it has done that. So now it says configuring Joomla, and done. And then normally if the video, then there you go, reloading the site. And the thing that I also done is and this is the admin, and this is the admin, so you can see that it works. There you are. And then I also added a little PHP-MyFPM container. PHP-MyFPM is not included in the default Joomla Tool Server because you don't need it when you deploy into production. But I have added a container for that, so that for local development, when you boot it up with Docker Compose profile PHP-MyFPM, it's a little profile that you add to it, then it will also create a PHP-MyFPM container, set up the connection, and then you get this. So you get a fully working, this is what you would get from a shared hosting environment, minus the cPanel, right? So that's what you get here. The code for this Joomla installation, since we're talking, I can actually show you. So this is not, to show you that this is real, this is where it is. So the code for this Joomla installation, I cannot zoom in, I haven't turned it on yet, is here. So there is a sites folder, and there's one Joomla site in it. Technically, this can handle multi-site. I haven't done that yet, installing multiple sites. It just installs one. But it creates a Joomla folder. The name of this folder is configurable. And then the MySQL is actually here. I'm putting it all on the file system. This is where the whole MySQL database is. The reason that all of this is in what is called a volume folder is because it makes it very easy to put it into a Docker volume if you want to, or in Fly's case, deploy it into what they call their volumes. In Fly, you can connect a volume to a Fly instance. So you can basically, to Fly, you can do this. This is the Fly pommel. And then you can say, where is, oh yeah, I haven't configured it here yet.
Isn't fast enough, the volume of Fly?
When it runs in Fly, it's as fast because it's mounted locally.
It's mounted locally?
Yeah. It's a mount. Yeah. So it's not running. It's not even running over Fuse. It's really mounted locally. So it makes it. This is really fast. You could locally move this volume into a Docker volume, and your site is just here. This is just your site, which is put here. And if I go to here, so this is just the site. This is just the admin. 3 yesterday. I'm not going to redo it because I need to download it over the local network, which is a little bit tricky. But it also runs Joomla 3, or it should. And then this is the PHP my admin for that. All right, so you have those 3. You can then further extend this whole setup. Going back to my keynote. So you can then further extend this whole setup with Grafana, which you could install into a container, or you go to their online offering. The metrics that come out of Joomla Tool Server already deliver this. I have already the dashboards done. I just need to put them there, and then you can have pre-made dashboards. You get data out, so you can see what your server is doing. You can use Sentry tracing. Sentry tracing can be enabled or disabled just through an environment variable. And then it will start collecting tracing information from the server and services itself, which is OpenSWOOL doing. If you want to implement it on a PHP level, that's possible too. Then you would need to install the PHP integration for Sentry into your application in your Joomla, and you could trace Joomla too. But here, this is happening on an OpenSWOOL level. This is basically the request being fired off to fast CGI and everything else that is happening internally. What you see here is cache revalidation that runs internally. Sentry tracing and exception handling. So any exception, any error that happens inside the server is being made available to Sentry, so you can see when something goes wrong, what is going wrong, and where it's going wrong, and how much it's going wrong. This is always a problem with Joomla sites. How do you debug a Joomla site? You don't. It's really, really hard. You need to turn on the debug, but then when did it happen? Under what circumstances? What is the information to replicate that error? You always need to go to your client and say, yeah, how did you get to that error? And then sometimes it depends on my computer, the network, some other variables. With Sentry, you can catch that because you catch the error and all the information around it and environment information around it when the error happens. And then you can set up alerts. So if the amount of errors goes over a certain threshold or the thing becomes unavailable, you get an email, a Slack notification, or even an SMS. And then logging, that's another nice one, Grafana logs, or wherever you want to sync your logs into. So the server is collecting logs all the time, but it's not writing those logs, which is default Docker. It's not writing those logs to log files. It's actually streaming them out. So you implement what is called a log sync that captures the logs, and then you store them somewhere. Here I'm using Loki, which is but you can also use Google Cloud Logs or any other. You could use LogDNA. There's a gazillion solutions of those. The great thing with Grafana logs is that it's free to 50 gigabytes. So there's quite a lot of logs that I can store if I don't send out too much. This allows me to see what the server is doing and query all the logs at all times. That's it, I think. Yeah. Well, let's make that. This is me in my. This is 10 years ago, 2007. Yeah. So this is what. 15 years ago. Sorry. One more. Anyway. So yeah, so this is where we are. So what you have right now is you have an environment that with a click of a button, in this case with one command line call, you can boot up and you get a full working Joomla. You can easily add additional containers to that if you need to have additional services running locally. And you can deploy that in any Docker hosting environment or in any firecracking hosting environment. With the nice addition that if you would choose for Fly, you get all the benefits and all the power that Fly offers, which is a really distributed application solution. Yeah. The reason I find this interesting is, and Brian knows that, is because when we initially, we had these ideas about how do you structure the project in terms of what if we want to have other kinds of technologies, other kinds of sub-projects? What if you want to have something that is not a CMS? What if you could do Joomla CMS, but you could also do Joomla, call it server, stack, or whatever you call it? Then it's a little bit the Apache model. I remember we talked about the Apache model back then, where Apache has incubator projects that bring in ideas, technologies, and incubate them, and then make them available. Something like this is interesting for two reasons. It allows Joomla to maintain and be competitive in the market of SaaS services, because I can build my own SaaS services, which I cannot with a normal PHP FPM environment. Like, I need async I/O to be able to do that, and I need that kind of performance of a Node.js or a Go, which I have here with PHP. I can tap into all the PHP extensions. I can choose them and I can configure them. This server, for example, is configured with PHP 8.1. It has opcode caching configured, and it has JIT configured. So its performance is top-notch because I can squeeze every little bit out of it. And I'm using a number of additional libraries to handle, for example, image and template generation. There's a file service in here that can generate images to handle responsive. I'll show that tomorrow in the workshop. We're going to do a workshop and show a little bit how all this works. Can create images on the fly, and instead of like going to a SaaS service to do that, or going to a PHP extension, which is actually quite slow, like a GD or an iMagick, which is all quite slow and it doesn't really work quite well. I've installed VIPs in here. You ever heard about VIPs? No. libvips is an image processing library, which is it's already like 20 years old, I think. It's really powerful because it uses a sequential model to transform images. It stores all the sequence steps that it needs to have to transform an image and then executes them one by one at the end.
Is the one that is default on Linux, right?
I'm not sure if probably VIPs is default on Linux. It could be. It could be. But it has adapters for PHP and for most languages, and most of the Node.js image libraries all use VIPs. Right? So I put that in there. I configured it, created a little service around it in Swool to make it handle that async, which makes it really fast. I can handle hundreds of images without a sweat. That's another example of this, and then I can show and see all the metrics of that come in here. So it would allow you to do all those things, which you cannot right now because you're constantly running against, I only have PHP extensions that I can work with, and I cannot add anything else, and the configuration I almost cannot touch either. This can. So that opens up the opportunity for a completely new type of development in PHP, Linux service development, async services, little tiny services that you could create because it's not that much code that you actually need that could provide all sorts of useful features to applications like a CMS or others. They could easily be deployed using this standalone and become their own SaaS service, or they could be deployed all together. That will work too. And second, you get a whole new ecosystem. Because Joomla ecosystem right now exists out of, let's say, 2 or 3 things. You have the extensions, you have the templates, and then you have the hosting providers. This creates, alongside the hosting providers, a completely new kind of ecosystem where people can start creating services to deploy this. That's one, but also start creating services to put in here. And those can be made available. That you can come up with all kinds of different things to do here. And then the really great thing is this allows you to compete with anything that is Node.js, anything that is Jamstack, anything that is written in Go, anything that people say, hey, the performance of, so I will go there. Then you go like, no, we have a solution for that. And it actually performance-wise, can compete with that.
Yes and no.
In a way, right?
The thing is, most of the web is moving towards edge computing, where you have, as you said, this you have like deployed everywhere. But actually, you cannot use Joomla from different deployed servers. I mean, probably you can by somehow orchestrating all of them to work together. But
You're underestimating me, but that's another talk. I can. I already solved that problem too.
okay, because if you can have like multiple deployed servers around around the globe, basically you
This is
compete with edge.
yeah, of course. This is the Fly.io is an edge competitor, is an edge solution. Like they are presenting themselves as building applications on the edge, distributed applications on the edge. That's where they're going for. That also makes them unique because they're the only one that are doing that at that ease of use and that scale. It's not something that Google can do with Cloudflare. It's not something that DigitalOcean can do with their app platform. I tried them all. I tested. That can really do this today is Fly. And then the challenge was, how do you install an application or a Joomla on there and make it a really distributed solution? There are limitations to solving that problem, right? But you can. And the answer lies into HTTP request repeating. You basically broadcast HTTP requests from the proxy all over the internal network so that all the nodes receive it. And each node can pick off if he needs to handle or not the request. I can keep 10 Joomla instances in sync like that. I tested it and I tried it. Actually, our JoomlaTools.com site works like that. We are running in 3 instances. We're running in LAX, Los Angeles, we're running in Amsterdam, and we're running in Singapore. Singapore. When I deploy on Fly a new version of JoomlaTools.com, I either deploy my code, the built-in API that sits in here can do a pull on Git, which is super fast because if I deploy not even a snapshot, if I deploy a single article on my site, right, then our articles are not all in the database, they're on the file system, right? So it is committed to Git. Git fires off a hook into the JoomlaTools server. The proxy receives this and broadcasts instances that are running at that time. All those instances simultaneously, I can show you tomorrow, all those instances simultaneously will do a Git pull and will automatically update. Each instance will reply back to say, hey, update completed. That update process for a single article takes 1 second. At the same time, all the instances will run a cache revalidator because I just updated an article. Now there are certain pages on my site that also need to be updated because I'm caching all of them as HTML in Cloudflare. So I run off a revalidator process that runs in here inside the API. That revalidator process will basically go like, I'm going to check which pages are not longer valid. I'm going to fire off HTTP cache purge requests against Cloudflare and automatically recache it. That whole process for a single page takes 5 seconds. If you do it with a deployment of the whole container, it takes longer. Deploying a container, as in 15 to 20 minutes per, 10 to 15 minutes approximately, depending on how much of the container you have cached, right? It takes a little bit longer. But small code deployments and updates work. The challenge is a little bit databases, and databases are always challenging. Like, how do you keep those in sync? MySQL isn't really the biggest and easiest for that. There are 2 answers coming, not included in the talk, because otherwise I thought the talk would be getting too long. But which, in a sense, would also become Cloudflare D1. No, I don't have internet. You need to look it up, Cloudflare D1. Cloudflare recently announced SQLite on the edge. And Fly.io is doing the same. Fly.io hired, forgot his name, Ben Johnson? Not 100% sure. I might be saying something wrong, sorry about that. But there's a guy that created something called Lightstream. Lightstream is a replication solution for SQLite because that was the only thing that was missing in the SQLite ecosystem. How do you replicate databases? How do you replicate them to other slaves? And how do you replicate them to a backup? And he created a solution for that. The guys from Fly have recently hired him too. So basically what I'm seeing is that the answer for Edge, which is what you were talking about, the answer that Edge is giving to the database problem is SQLite. Yeah, yeah.
Because it's Postgres, you can just...
Fly.io runs Postgres. So again, they run it replicated. So the problem is solved there. But Joomla doesn't support Postgres. So, you know, well, the ecosystem in a whole.
The ecosystem.
When I talk about Joomla, Brian,
I don't use cores. So.
the bigger whole. It doesn't. So you're kind of like stuck there. We were experimenting yesterday with WordPress and see how they solve that. They don't. Initially, not in the core, but there is a guy that created a SQLite adapter for WordPress, and it's really interesting. He is translating queries. So the extensions and the plugins in WordPress don't need to change themselves. He just translates the queries, and we tested a little bit, and it actually works. So we now need to try and see if we can set up a WordPress on a SQLite, but if that's possible, you can actually have a WordPress on the edge. So what I'm saying is, it's time that Joomla starts taking SQLite seriously and start creating a SQLite adapter so that extensions can adapt themselves to that. Because then running Joomla on the edge would be a piece of cake. Backups would no longer be a problem. Maintenance of databases would no longer be a problem.
That would be a problem.
Yeah, but
For somebody.
that's a different thing. Actually not, right? Because if you then want to develop a backup solution for those databases, it becomes really simple. You just need to fetch a file. You can replicate that easily to different storages, and you can and intersync it. So the whole problem that you have with MySQL with how to handle backups in a SQLite case is basically gone. Plus, SQLite comes with some really awesome features, like they have their own internal backup. That's one. They have full text search. And there's a couple other features that implement natural language search and stuff like that are also available. It's actually a very nice ecosystem that I wasn't really aware of until I started digging into SQLite and was like, hey, this is a little bit more than just SQLite. It's a really decent database. You could run almost any Joomla site on SQLite and it wouldn't budge. And a lot less resources you need. I now need on Fly, to run Joomla on Fly, I need 512 megabyte instance. But that's 350 megabytes for MySQL memory. If normally, and I can run Joomla tool server with 100 megabytes memory. So if I could put it on a 250 megabytes instance, it still runs and you don't break it easily, specifically when you have 3 of them running. Oh yeah, I completely agree. There is still.
If you swap MySQL to SQLite.
Yeah, swapping MySQL to MySQLite. Apache, I'm not really sure of. The reason I chose Apache is because configuration-wise, it works quite well. I didn't want the thing that was that I was like, I don't want to move from the LAMP stack. Let's just do this with it and see how far that I get. And because Apache in this setup is running as a proxy. It's running npm event, and I optimized it. There's actually not that much difference by swapping that out for an Nginx. It might use a little bit more memory because of the way, but it also forks the servers, the max servers that it can run are limited in terms of the overall memory that you have. So again, you know, I don't think the differences are going to be that big. There could be differences, but not that big. But MySQL is one that takes a lot. So in Fly and in all those solutions, you're paying for memory, basically. You're paying for memory and CPU. The less memory that you need, the lower the cost. 265 megabyte instance is free. I can run 3 of those for free. So if you can run a Joomla in there in 250 megabytes memory, then you need something like SQLite, because with MySQL, it won't work unless you host the MySQL somewhere else. But then you get all the problems with the synchronization, and you start all over again, right? So yeah, that was the talk. Tomorrow we're doing a workshop. We're going to show a little bit of Joomla Tools pages, and then how you run that in Joomla Tools Server, and what benefits that gives in terms of, for example, resizing images, performance, cache. Most welcome to join us there. It will also be in English because my French isn't good enough for that.